Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about equal complex numbers now. Please, before you come to this video, make sure you've watched the previous video and understood all the concepts because we're building on the information that we've discussed previously. And also, before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. You have to do so that when I post new videos, you'll be the first person to know. All right, so let's go. First thing first is that we're having two complex numbers, and how do you know if they are equal? So let's assume I have this. So we have A plus BI is equal to maybe C plus CDI or something like this. And you were told these two complex numbers are equal. What it means is that the real part, A, must be equal to C, okay? And the plus B must be equal to the plus D. Is that making sense? So for this to be equal, A must be equal to C, and also the plus B must be equal to the plus what? D. So that means you have to take note of the signs as well. Is that making sense? So you don't just assume or you say, oh, they have to, for instance, they have to be equal because B is equal to D. No, you have to include the signs of both the imaginary number as well as the complex numbers, all right? So if, for instance, we had something like A plus B I is equal to minus C plus D I. So that means for this to be equal, A must be equal to what? Minus C. Are you seeing it? And also B must be equal to what? D. And also, it's not just the B, the plus B must be equal to the what? The plus D. All right? So that's what I'm just trying to say. So that when if two complex numbers are equal, the real part have to be equal and the imaginary part also have to be what? To be equal as well. All right. So let's get cracking and let's solve some questions here. Because I know some of the students do take notes, some of the viewers. So what I'm going to do, I'm going to write what I just said so you can take note of it as well as so that you can have something to revise when it's time to do so. So now there are three things to keep in mind when we're talking about equal complex numbers. There are three rules, okay? So is that if two complex numbers are equal, okay? So that means if two complex numbers are equal, now the two real parts have to be equal. The two real parts are equal. Okay. Also, the two imaginary parts are equal. And also, you have to be careful to include the signs. Okay. So the two complex numbers are equal. The two real parts have to be equal, the imaginary part as well as the sign. So what I'm trying to say then is that hence, okay, so hence, if for instance we're told that two complex numbers are equal, so if we're told that A plus BI is equal to, okay, let's assume it's equal to maybe C plus DI. So that means I'm saying that A plus BI is equal to C plus DI. All right. So it means that for this to be equal, the real part, A, must be equal to what? C. I see it. So that means, or you can say the positive A is equal to the positive C. Okay. And then plus B must be equal to plus D. Is that making sense? So plus B must be equal to plus D. So depending the signs that are there, they have to be what? The same. Is that okay? So that is basically it. So the real part has to be equal, as well as the imaginary part has to be equal. All right, so let me pick some examples here. Let's pick some examples. Let's assume we have this example. I'll just pick two or maybe just some. Yeah, so let's see how we go. Number one, we're told that if x plus jy is equal to 5 plus j4, we're now told to find x and y. All right, we're told to find x and y. Now, this is pretty much straightforward. So we're told now that these two are equal. So x plus jy is equal to 5 plus j4. So for this to be equal, the real part has to be the same. So that means x must be equal to what? 5. And also plus y, are you seeing it? Must be equal to plus 4. Okay? Then plus y must be equal to plus 4. So therefore, y is equal to what? 4. So remember, I said you have to take note of the signs as well. Okay? So it's very important because if it was minus, so plus y has to be equal to minus 4. So you have to be very, 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 very careful in this play. I know some of you might say, oh, Mr. Terry, this is very easy. Give me something more interesting. All right. Let's go to question 2. All right. Let's go to question 2 and see what we can do here. So question 2. Let's assume if we have 2 minus a 2 minus aj5 divided by 1 minus jb is equal to 3 minus j5. We're told to find a and b. Is that making sense? We're told to find a and b. All right. So personally, I prefer to rewrite this again as 2 minus a minus 5i. It's exactly the same thing as complex numbers, but I just want to write it in this format so that it will be easier for me to write and calculate. All right. So I'm going to put the coefficient before the imaginary parts. Okay. So it does not affect anything, basically. It's just that it will be easier for me to, when I'm writing, just my personal preference for that. Okay. So what I'm going to do, I need to get rid of this fraction, okay? 1 minus bi, so I'm going to multiply both sides by 1 minus bi to get rid of the fraction, so that will be easier for me to work with, all right? So 1 minus bi, this is going to cancel that. So it's going to give me 2 minus a minus 5i will be equal to 3 minus 5i into bracket 1 minus bi. Okay, so now we've gotten that. So the next step is that I'm going to open the bracket on the right-hand side. So if you remember, I told you when we're talking about basic algebra, I said a plus b, when you want to multiply with c plus d, is going to give us a times c, will give you ac. A times d is going to give you ad. B times C is going to give you BC, and B times D is going to give you BD. Is that making sense? So we talked about this in a previous video. So that's why it's very important that you try as much as possible to review the previous video before coming to the next, okay? So that because we build on existing knowledge, okay? All right, so that's been said, I'm going to apply this to solve this question here. I'm going to open the bracket. So we're going to go straight. So it's going to be 3 times 1 is going to give me 3. We're going to have 3 times minus b is going to give me minus 3bi. Okay. 5 times 1 is going to give me minus 5i. Are you seeing it? I'm going to have minus 5 times this is going to be minus times minus is going to give me plus. 5bi squared. And this is going to be equal to 2 minus a minus 5i. Now, but also I squared, we can break down I squared. Remember I told you in the previous video that I squared is equal to minus 1. We've talked about this before. So that means I can rewrite this again as equal to 3 minus 3bi minus 5i plus 5b minus 1. And it's equal to 2 minus a minus 5i. Okay? Now you open the bracket, it's going to give us 3 minus 3bi minus 5i minus 5b. I'm going to give us 2 minus a minus 5i. Is that making sense? So the next thing as well is what I'm going to do then is that I'm going to collect all the imaginary parts together. And I'm going to collect all the imaginary, the real parts together. So the real part is going to be 3 and minus 5b. So it's going to be 3 minus 5b. And the imaginary part is going to be minus 5i and minus 3bi. So these are the imaginary parts here. And this is equal to 2 minus a minus 5i. So I can also write the right-hand side like a real number because the real number is a plus bi. So the a is the real part. The b is the one that has the coefficient of I. So we can now say this is the same thing as saying it's going to be 3 minus 5b minus what is common between both of them? We have it as a 5 plus 3bi. Are you seeing it? And this is going to be 2 minus a minus 5i. So you can see now we have two real numbers on both sides of the equation now. All right. So you can see we have real number here and real number here. So for this to be equal, this real number has to be equal to this real number here. So we can now say 2 minus a must be equal to 3 minus what? 5b. Okay. Now also we can also do this as well. The second real, the imaginary part as well has to be the same. So minus 5 must be equal to minus into bracket 5 plus 3b. So minus 5 must be equal to minus 5 plus 3b. So you're going to have minus 5 is going to be equal to minus 5 plus what? 3b. And if you want to open this, it's going to be minus 5. Minus 5 is equal to minus 5 minus what? 3b. Okay? So if you want to do it that way, you will get something like that. Now, the next thing is that we can then equate both of them. All right? You can then equate both of them, or you can then want to simplify. So I can now say, because we have minus minus, this, I can rewrite this as well as saying, from this part here, okay, since we have minus minus on both sides, it can cancel out. So you're going to give us 5 is equal to 5 plus 3b. So if you want to solve, you can solve with this one, or you can solve with this one. It does not really matter, okay? And just because I'm aware that students really, really don't like the negative sign, so I'm going to select the second one, okay, to solve with it. But you can use any one and you should get the same thing, okay? So we can then simplify this, okay? We can now get, we multiply both sides by minus 1, okay? So multiply both sides by minus 1, okay? So it's going to be minus 5 is equal to minus 5 plus 3b. So multiply here by minus 1, you multiply here by minus 1, and that'll give you 5 is equal to 5 plus what? 3b. Okay. Now we had this part here on the right-hand side, and we have this part now on the left-hand side. So now, as you can see, the B in the right-hand side with the green pen is exactly the same B on the left-hand side, as well as the A. Now, but what you can do, you can solve this simultaneously. You can decide to use simultaneous equation. You can decide to use the substitution method or the elimination method. I've discussed each of these methods before, so you can go back and have a look. So I can decide to rewrite this now by solving it simultaneously, so that because I know that they are both the same thing. So because I know that 2 minus a equal to 3 minus 5b is exactly the same thing as 5 equal to 5 plus 3b. Now, what you need to understand is that for these two to be the same, it means that the a here has to be what? 0. So that means I can rewrite this again as saying 5 plus what? 0a. Nothing different. Now, from here now, we can now solve this. So what you do, we then get rid of the b, okay? So you can easily get rid of the b. Then I'm going to multiply this part here by 3 and multiply this part here by 5. Okay? So I'm using the elimination method. In basic algebra, I talked about the elimination method. I talked about the substitution method. So it's any one you prefer, you can use here to solve, okay? But I'm going to use the elimination method here. So you're going to multiply by 3. It's going to give us 6 minus 3a is equal to 3 times 3 will give me 9 minus what? 15b. Then 5 here is going to give us 25 plus 0a is equal to 5 times 5 is going to give us 25 plus 15 what? B. All right, so in order for me to get rid of this, I need to add. So because if I add minus 15b, we cancel out plus 15b. So I've discussed this earlier. So please make sure you've gone back and watched the video on how to solve simultaneous equation using the elimination method if you're not very conversant with that. So 6 plus 25 will give you 31. Minus 3 plus 0a will still give you what? Minus 3a, okay? Now 9 plus 25 is going to give you 34, okay? So now we then have this. So we now have 31 minus 3a is equal to 34. I'll take 31 to the other side. So we're going to have minus 3a is going to give us 34 minus 31. Minus 3a is going to give us 34 minus 31. It's going to give us 3. Then if we're looking for a, we'll divide both sides by minus 3. Then divide by minus 3. So this is going to cancel this. So therefore, we're going to have a is going to become 3 divided by minus 3, and that will give you minus 1. So therefore, we can now say a is equal to what? Minus 1. Now we've gotten a, so we can find b. So what we need to do, we can then substitute it into any of this equation here, all right? So I can decide to select the 2 minus a equal to 3 minus 5b. So any of them will be fine. But I'm going to select the first one. So, but we know that is 2 minus a is equal to 3 minus 5b, okay? So substitute a into this. So it's going to give you 2 minus the a is minus 1. It's equal to 3 minus 5b. So we can now say minus times minus is plus. So it's going to give us 2 plus 1 is equal to 3 minus 5b, okay? 2 plus 1 is going to be 3. 3 is going to be equal to 3 minus 5b. All right, so what I'm going to do then is that I'll take 3 to the other side. So it's going to be 3 minus 3 is equal to minus 5b. Then I divide both sides by, before that, let me just solve this. 3 minus 3 will give you 0. It's equal to minus 5b. And I'm looking for b, so it's going to divide both sides by minus 5. You divide both sides by minus 5. So therefore, B is going to be 0 divided by -5 is going to give you 0. So that means for this question here, the A is -1 and the B is 0. So therefore, we can now say the A is equal to -1 and the B is equal to what? 0. And that will be the answer for that. All right, so that is it for equal complex numbers. You can go back and you can solve more questions. You can solve more questions using the textbook, using the worksheet, and that will be fine. The next one we're going to talk about solving quadratics with complex numbers. Okay, so how do you solve quadratics with complex numbers? All right. So the first thing first is that I want you to try as much as possible to solve more questions. And if you have any question, please send me an email and I'll get back to you. Is that okay? So I'll see you in the next video where we're going to solve quadratics using complex numbers. All right. See you soon. I'll talk about solving quadratic with complex numbers. See you soon.